Welcome back. Dale Myers with Student Advance. In this video, we're going to give you the best definition of the distributive property of multiplication and some examples. So, that being stated, what does it mean to distribute? If I walked into the room and said, I have 100 pieces of candy I'm willing to distribute, what am I going to do? Right, I'm going to pass them out. Now, if everyone stays in the room and I distribute my 100 pieces, will it still be 100 pieces in the room? Yes, it will. It's just different people will have it, right? That's what we're going to do in the distributive property. We're going to start with a certain amount. We're going to distribute, give away some, or divide the total, but it's still going to be the same amount. Right here, I have a 4 by 5 array. 4 times 5, right? Now, you know that 4 times 5 is 20. Most of you already know that. But just like I said we could distribute and break something up, let's rewrite the number 5 as 1 plus 4, symbolized by one green row. This is 1. There's the 4 times 1. Here's my 4 white ones right here, right? So this is 1, and here's 4. 1 plus 4, well, that's my 5, right? But it was still we were multiplying 4 times 5, so we still have to multiply these by 4. But each one gets multiplied by 4. You can think of it this way. I took this 4 and distributed. I distributed this 4 to that 1. 4 times 1 gave me 4. And if you look, I have 4 right here. Then I distributed my 4 to that 4. 4 times 4 is 16. And if you count all of these, you will see there's 16. Well, 4 plus 16, yep, that is 20. And that makes sense because 4 times 5 is 20. The only thing we did, we took the 5 and broke it up into a sum of its add-ins. That's what the distributive property does. It allows you to take two numbers, break them up into two add-ins, and their sum is the same as if you multiplied it by the original number. A little bit of practice is in order. Let's jump into it. So, for example, 4 times 10 plus 3. Now, again, order of operations. Absolutely. We could go ahead and do 10 plus 3, and we'll get the same answer as if we distributed. I'm going to leave you to do that on your own, but we're going to distribute. This 4 wants to distribute to that 10. 4 times 10 gives me 40. This 4 must also distribute to everything within the parentheses. Think of the parentheses like, remember I walked into the room and said, I'm going to distribute 100 pieces of candy to everyone in the room? This 4, or whatever number or variable is outside, has to be distributed times everything within the parentheses. So 4 times 3 is 12. I add these together, 40 plus 12, 52. This was actually the distributive property of multiplication over addition because we're adding. Guess what? Do you think it works over subtraction? I think so. Yes, it does. So, for example, the distributive property over subtraction. If I gave you 5 times 40 minus 6. Well, that's kind of a big number. Don't worry about it. This 5 must be distributed to that 40. Well, 5 times 4 is 20. So 5 times 40 is going to be 200. That 5 is also going to be distributed here to that negative 6. That's not 6, that's negative 6. 5 times 6 is 30. So 5 times negative 6 is negative 30 or minus 30. Okay? 200 minus 30, oh, that's 170. Simple enough, right? So again, we're using the distributive property. We did it over addition. We did it over subtraction in our last example. Now, let's look at what happens if we have a variable. Yes, if you're in middle school, high school, or adult education or college, you know that we can do this with variables too. So if I gave you, let's say, 7 times x plus 4, it does not matter. we want to distribute our 7 to everything within the room, our parentheses. This 7 has to go talk to that x, then it's going to go and visit that 4. 7 times x is just 7x. 7 times 4 is 28. This is how that works. This is the distributive property with variables. Now, let's see. It was a couple other points that I wanted to do. Just show you guys a couple of quick tricks. If I gave you a big number that you didn't know how to do, let's say 85 times 7. You could go and do old school math, and there's nothing wrong with it. That's the beauty of this. It works no matter which way you do it. But what big number is close to 85? A simple number to work with, like 80, right? It's a multiple of 10. So I'm going to rewrite 80 as 80 plus 5. Are you okay with that? 80 plus 5 is 85. But it was multiplied by 7, so it all has to be multiplied by 7. Now, it doesn't matter if that 7 is in the front or in the back. Everything directly outside of parentheses means multiplication. We now have to use the distributive property. And now this 7 has to go distribute to 5. Then it's also going to come over here and distribute to the 80. Doesn't matter which one you do first. 7 times 5 we know is 35. 7 times 8 is 56. So 7 times 80 would be 560. It's not too bad, right? Well, 35 and 60 is 95. So this is 595. I should have boxed that in earlier too. That was a different problem, but I like to box my answers, make it easy for your instructor to find if you're in classroom. So again, this is just the distributive property. We actually, so we just broke it up. Now, what we also can do, and we're almost there, guys. One more. We can do it like, what if I gave you something like 99 times 6? Again, we can write old school multiplication and get the answer, but we can say, well, 99 is very close to what number? 100. 100 minus what gets you to 99? 1. So 99 is the same as 100 minus 1. So we just rewrote that. And then we need to multiply it by 6. Okay, I think we can do this. What's 100 times 6? 600. What's 6 times 1? Because remember, we're distributing that 6 to everything. 6 times 1 is 6, so minus 6. 600 minus 6, 594. Again, go back and double check your math. So this has just been the distributive property of multiplication. With some examples, we gave you the simplest definition, guys. Just distribute it, break it up, break your whole into different amounts, but you end up being the same. Just like 4 times 5 is the same as 4 times 1 plus 4. It all equals 20. My name is Dale Myers with Student Advance. If you need more practice, go to studentadvance.com. Check this video for a link, and it'll give you some practice problems at our website. And if you need more help with tutoring, we are happy to assist. More specifically, we are here to help you develop your potential, your child's potential. Absolutely, make no mistake about it. We love math and science, but what we really do is try to help good, amazing people find the courage to create their amazing life. Again, Dale Myers with Student Advance. Take care.